today. Good afternoon. Welcome to geometry class. We're going to finish up chapter 3 today, section 3.6. We're going to talk about perpendicular postulates and theorems about perpendicular lines. We've done a lot with parallel lines. We even proved parallel lines, which we're going to have to review a lot next week to get ready for our test. But this last one, talks about perpendicular theorems. So we're just going to go over these. We have our handout ready. We're going to highlight these things up on our handout. So I think on the back, if you find theorem 3.8, it's about halfway through on the back. If two lines intersect to form a linear pair of congruent angles, meaning they make a line, then the lines are perpendicular. So let's think about it. If I have a line, and I know that two angles are congruent, what angle measures do they have to be? How many degrees is in a line? 180. And if these two angles are the same measure, what do they have to be? 90. They have to be 90 degrees. Does that make sense? So if I have two lines that intersect to make 90-degree angles, then they have to be what kind of lines? Perpendicular. Right? So that's why this theorem exists. Alright? Because it said, if two lines intersect to form a linear pair of congruent angles, so if they make a line and they're congruent, then they have to be right angles, which means these two lines have to be perpendicular to each other. Okay? So sometimes our theorems are just stating the obvious, and that's one of those. Right? So the next theorem, find theorem 3.9, which I believe is just right underneath. It says if two lines are perpendicular, then they intersect to form right angles. So that's basically just the definition of perpendicular lines. Right? If they form 90-degree angles, then they're perpendicular, or if they're perpendicular, then they form 90-degree angles. So that's basically just the definition of perpendicular. All right? We know that. So we got that one marked, 3.9. All right, the next one is section 3.10, which we are going to do a little math with this in a little bit. If two sides of two adjacent, okay, clue word. What does adjacent mean? Do y'all remember? Y'all remember what adjacent means? Adjacent means they touch each other. They're right up against each other. Okay? So if two sides of two adjacent, acute, what does acute mean? Less than 90-degree angles are perpendicular, then the angles are complementary. What does complementary mean? Okay, so if I know that these two are perpendicular lines, and these two are acute angles that are adjacent from each other, then together they make 90 degrees. They're complementary. Again, this one's kind of stating the obvious, but we're going to use this one a little bit to do some algebra with to find some angle measures. Okay, so that was theorem 3.10. And then we have the perpendicular transversal theorem, which is at the bottom of the page. So if we have two lines that are parallel, and this picture shows two parallel lines, how do we know they're parallel? They have a little arrow, matching arrows. Okay? So it says if a transversal, that means a line that goes through the two lines, is perpendicular to one of the parallel lines, then it is also perpendicular to the other. So if we have a transversal that's perpendicular to this parallel line, then it's going to be perpendicular to this one as well. Okay? It should be common sense, yes. But this is just stating it. This has been proven. That's why it's a theorem. It's been proven. That's why it's a theorem. So yes, a lot of times theorems are like so obvious. Okay? This is one of those as well. Yeah. If we're perpendicular to one line, and that line's parallel to the other one, so then that one's perpendicular to that one as well. Last one is the one that kind of goes sideways because I ran out of room. And this is kind of like the converse of that last theorem. Remember, converse swaps the order? Y'all remember that? Converse theorem swap the order? So this is kind of like the converse theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if I have a transversal that goes through two lines, and both of those lines are perpendicular to that transversal, then those two lines must be parallel to each other. So it is pretty much the converse of the one before it. Okay? So if we're perpendicular to both lines, then those lines must be parallel. So I think we've highlighted most of all that sheet. So the ones we covered are going to be fair game on your Chapter 3 test. I do have one example that's going to help you work a problem. So on your notes, this will be your one little example for the day. Y'all want 20? Okay. Draw the picture, it helps. Your notes will not make sense if you don't draw the picture. So in this example, they tell me line FG is, what's this symbol? Perpendicular to line GH. Okay, they tell me they're perpendicular. So here's FG, here's GH. Okay? We want to find the value of X. Now, which one of those theorems, and you can just tell me the number from the handout if you want to, does this one look like? 3.10, right? So theorem 3.10 says if two sides of two adjacent acute angles are perpendicular, then the angles are complementary, which means they equal. And it makes sense. This is a 90-degree angle, right? Right? So that means that these two together must be also 90 degrees because all three of these angles make a line. Y'all see that? So there's 90 degrees left over to split between these two. Does that make sense? So how would I set this up to solve it for X? Add them up and set them equal to 90. So I'm just going to say X plus 15 plus 39 equals 90 degrees. And we can combine our like terms. What's 15 plus 39? So X plus 54 degrees equals 90 degrees. Subtract 54, and X equals 36 degrees. So could y'all do some of those on your own? All right. This is the end of section 3.6 and the end of chapter 3. Have a good day.